Hello everyone, in this video I want to explain the C problem. Tiles come back in around 888 div tree. So let's remember that he had series of n tiles and a number k. The tiles were numbered from left to the right, and each tile had color Ci. If you stand on the first tile and start jumping any number of tiles right, you can get a pass of length p. The length of the pass is the number of tiles you stood on. So Lad wants to see if it's possible to get a pass of length p such that it ends with index n. So it should include last index. P is divisible by key. The pass is divided into blocks of length exactly k each. So tiles in each block have same colors. So for example, in this case, you start from first and you should end with you should be index n at the end. So you are required to choose one and another, this one and this one. So you are done with the first one, and you don't have to collect ones in the middle. Just skip them all, and from this place we should just count the number 4, because in the last index we have 4. So as you can see here, it says that the pass P should be divided to exactly to k numbers, and blocks should have same colors. So numbers with same have the same colors, so we can choose 1, and so since k is 3, we should choose 3 of each. For the first index 1, so we should collect 3 ones. This is good, and till here we can get 3 ones. So now we can choose 3s, but it's not required, so we just skip it. From this place we should count 4s. So 1, 2, 3. So 1, 2, 3. So we are done. This answer is yes. If it's not possible, it's no. So now as you can see here, in this case, the 6th case is 1 and 1. So the first one is 1 and last one is 1. You can just choose 1 and 1. So this is also yes, because you are starting from this place. Let me show. It ends with index n. Yes, it ends with index n. The p is divisible by k. Yes, it's divisible by 2. The pass is blocks into exactly of length k each, so it's one block with 2 elements. The pass is divided into blocks of length k each, so the tiles have same colors. So as you can see, the same colors. So now we have to implement this. By the way, one more case. Look at this. So we should start from 1. So 1. So what was the key? K is 4. So 1, 2, 3, 4. We collected 4 ones till here. Now we have to collect 4 twos. So we can collect 4 twos if we start from the first index, but we cannot do this because we already come to this index. So we should start from this place, so we can only get 2 twos. So the answer which we know. Now we should implement this. So we should first input n and k. So just series n. So we inputted all of the things that we need. Now we should start counting from the first index. So we will get one count that would be 0, and so from the first index if this number in this index is equal to the first item, so we will add 1 to count. And now we should check if count is bigger than if so, what you have to do, if the count is bigger than or equal to the k, we can just save this index. So as you can see here, at first I will just put 0 to index. So, and if that's the case, index would be I that we have come, and just break it. So now we will get a second count that's also equal to 0. Now we should start from the index we have come, that's in ing plus 1 till the end. So this is also the same, but this is not with the first one, and this is with last one. Now we should check if so this AI, oh I mean CI, C0, CI, C0. Now we count 2. So we can check if count 2 is bigger than k or equal to k. We should yes, otherwise no. But this case is not including one case, so as you can see here, the sixth case. So sixth case, it should be true, but this is no. The reason is that in the sixth case we are starting from 1 and collecting till here, and then we are trying to collect, so we should check or count is bigger than or equal to k, and the first index is equal to the last index. So now it's included, but one more case is not included yet. I will explain it. So here, as you can see, seventh case should be no. This one. So the reason is that sometimes we are not getting this statement, so ing is just becoming 0. So we should modify it. If count is less than k, our index would be n. Okay, so that this loop will not work and count 2 would be less. So all this sample test is passed, so we'll try to submit our code. Oh, accepted. Try to implement this by yourself. So most important thing is understanding the logic. Goodbye.